Hi, Math 3. Welcome back from spring break. Hope you're able to relax. I'm sure a lot of you caught up on sleep and watching a lot of videos and TV and playing games. I know I did a lot of that. Since we had the week off, I made a little mixed review that you hopefully were able to do on Monday, March 30th. And here's the video of going over it so that you can hopefully learn from any mistakes that you may have made. Questions 1, 2, and 3 are all from lesson 1 and lesson 2 that we worked on last week. 4, 5, and 6, these are old problems from previous units, maybe even number 4 is from first semester, but those are questions that pop up on this unit's summative. So that's why I threw those on this worksheet so we can make sure we're practicing those and getting ready for the summative. So on number 1, we have a bank with a 3.75% interest on a savings account compounded annually. Brian deposits $1,800 into the savings account in 2020. Remember, the percentage, we want to write that as a decimal when we put it into the equation. And we do that by moving the decimal point 2 places to the left. So that's 0.0375 as a decimal. In part A, we want a function to represent the amount in the savings account A of t as a function of how many years t since 2020. So the generic equation from last week's notes would be the principal times 1 plus or minus the rate written as a decimal over k, where k is the number of times it's compounded per year, raised up to the k times t. So in our particular problem, it's compounded annually, so we don't really need to worry about k so much because k just equals 1 because it's only compounded once per year. So then we're going to do a of t equals the principal, the initial amount of $1,800 times 1, and then since we're earning interest, we're going to do plus, and then the rate as a decimal, so 0.0375. And again, I don't really need to worry about k because k is 1. So I would be dividing by 1, so I don't need to write that. And then raised up to the t times k. Again, I don't need to worry about k because k is 1. So basically, that would be it for part A. Part B, how much money will be in Brian's account if he leaves it in the bank until 2032? So we just use our equation. T is the number of years since 2020. So we're basically doing 2032 minus 2020 to make sure that we are using the right T value. So 12 years for T. A of 12 equals 1,800 times 1. I'm just going to write this as 1.0375. So I'm just adding the 1 plus the decimal and then raised up to the 12th power. Grab a calculator. And remember, you could use that Calculate 84 app that I showed you on the iPads if you don't have a calculator. That way you can type these things in. And since this is money, I'm going to round to 2 decimal places. So I get approximately 2799.82. So $2,799.82 approximately. On number 2, at 10 a.m., the amount of acetaminophen in a person's body is 500 milligrams. Each hour, the amount of acetaminophen decreases by 11%. Write a function that describes the amount of acetaminophen in the person's body 8 hours after 10 a.m. So this is going to be an exponential problem. And since it decreases by 11%, we're basically saying normally we would have 100%, but we're going to decrease. We're going to subtract 11%, and then that is going to be written as a decimal. So instead of 89%, we'll write that as 0.89. That's going to be our R value, our constant, our common ratio, I should say. So then, in order to set up this type of problem, they didn't really give us a name for the function. So we could just say y if we want to, or if you wanted to do like a of t or something, that would be fine. I'm just going to say y. And then I'm going to take my initial amount, so the 500 milligrams, that's my initial starting value, and then times my rate, or I keep saying rate, my common ratio, so 0.89, because I'm going to be decreasing. So that number, the 0.89, is in between 0 and 1, since I'm going to be decreasing. And then raised up, I'm going to say to h, because that is the number of hours. And that's all we'd be looking for on part A. On part B, to the nearest milligram, how much acetaminophen will be in the person's body at 1 p.m.? So remember, h is the number of hours after 10 a.m. So to 11 to 12 to 1. So that would be 3 hours later. So we're just going to use that same formula we came up with in part A, and then we're going to plug in 3 for the h value. So grab your calculator or pull up Calculate 84 on the iPad, plug this in, and it says the nearest milligram, so you're going to round to the nearest whole number. So about 352 milligrams. For number 3, the population of the city of Whoville was approximately 25,600 in the year 2014 and has been continuously growing at a rate of 1.1% each year. Write a function that describes the population as a function of the number of years t since 2014. So the fact that it says continuously is a huge hint that we need to use that A equals P times E raised to the RT, so PERT. Remember, the rate should be written as a decimal, so move the decimal point 2 places to the left, so 0.011. And then for the function, we would do something like A of t equals the initial population, so the 25,600, times E raised up to the rate written as a decimal, so 0.011, and then t just stays t for the initial function. In part B, we want to know the population or predict the population in 2021. So 2021 and 2014 to figure out the actual number of years. That gives us 7 years. So we're going to just use 7 as our t value in the function we came up with in part A. So grab your calculator and type it in. 600 times e to the 0.011 times 7. And then since this is people, I'm going to round to the nearest whole number. So 27649. So about 27,649 people. So number 4, this is a blast from the past. This is from first semester. We want to solve this inequality and then write our answer in interval notation. Since we see an x squared term and an x term, we want to get everything on one side of the inequality so that we can set it equal to 0, so that hopefully we'll be able to factor. So I'm going to subtract 30 from both sides of the inequality. That way everything is on one side with 0 on the other side. And then I want to try to factor. So all of those terms are divisible by 2. So I'm going to factor out a 2, since that's our greatest common factor. And then looking at my leftovers in the parentheses, it's a basic trinomial. So when you're trying to factor a basic trinomial, you want to multiply to the number in the back, and then you want to add to the number in the middle. So I'm looking for 2 numbers that multiply to -15 and add to -2. So -5 times 3 is -15, and -5 plus 3 is -2. At this point, I want to set each factor equal to 0 and solve for x. So that first equation, 2 doesn't equal 0. That doesn't make any sense. You just cross that off. It doesn't work. And then plus 5, so x equals 5 is one answer. Minus 3, so x equals negative 3 is the other answer. And then there are multiple ways to do this. Your teacher last semester may have had you do test points. I actually kind of like doing a little sketch of the graph and then just looking at it. So I'll go over here to the right, and here's a little sketch. Here's my x-axis, here's my y-axis. I'm going to put 5 right there, negative 3 over here. So those are my x-intercepts. And then if I look back to this step right here that I just starred with the green star, this is a quadratic. It has an x squared, so I know it's going to be a parabola. I have a positive a value, which helps me know my end behavior. So basically, since it's a positive a value, I know that both ends of my graph should be pointing up. And then since it's a parabola, I know I have my two x-intercepts of negative 3 and 5. So my picture should just look something like this. You know, it has to be concave up because of that positive a value. So then all I do is I just look at this picture to figure out when this, let me change colors. So I have to figure out when this is greater than 0. So since this green graph over here is 2x squared minus 4x minus 30, when it's greater than 0, that happens right here, and that happens right here. So I want to look at that graph from left to right. So from negative infinity, like when x is negative infinity, to negative 3, we are above the x-axis, so we're greater than 0. So I would do a normal curved parentheses for the negative infinity. And then since this is a greater than sign as opposed to a equals sign, I'll do a curved parentheses. If this greater than sign had the little half equal sign under it, I would want to do a square bracket on the negative 3. But I want to do a closed circle. And then I'll do a little union symbol. And then the next time that that green parabola is above the x-axis is from 5 to infinity. From an x is 5 to an x is infinity. So then that would be my answer in interval notation. Looking back at my graph, since I want to know when the function is greater than 0, I'm actually going to open up those circles. So let me erase this real quick. That negative 3 dot, oh, of course that would happen. Let me just do this. Technically, I think this should be an open circle, and then that should be an open circle instead of closed circles, since we're not supposed to be including 0. All right, last two. On number 5, they already partially factored this for us, and it's already equal to 0. So what we do is when you look at that first set of parentheses, that's a difference of 2 perfect squares, meaning I can factor it a little bit more. So I'm going to do the square root. Let me just finish writing this. I'm going to do the square root of the first term. So square root of x squared is x. That goes in the first set of each set of parentheses. And I'll do the square root of the second piece. So square root of 100 is 10. Make the first, or one of the parentheses positive and one negative. It doesn't matter which one's which. And then I just drag down the 3x plus 5. So now I have 3 linear factors all being multiplied together, all equal to 0. So I just set each factor equal to 0 and solve for x. So that's not too horrible. Not horrible at all. I feel like that should be one of the easier questions on the summative. So subtract 10 on both sides. Add 10 on both sides for the second equation. And then that last one is a two-stepper. So minus 5. And then divide by 3. So there you go. Negative 5/3, 10, negative 10. All right, last one. So we see a square root sign. So this is a radical equation. Whenever you do a radical equation, you want to isolate the radical first, meaning you want to get this part, the square root of 7x minus 5, you want to get that all by itself on one side of the equal sign first. So I have to add x on both sides of the equation to start, like so. Now that the square root is isolated, I want to undo the square root by raising it up to the second power. Whatever I do to one side of the equation, I have to do to the other side to keep it balanced. When you square a square root, it cancels out. And then that x plus 1 squared on the right side, I have to write out as x plus 1 times itself. I'm going to drag down the 7x minus 5. On the right side, I'm going to FOIL. So x times x is x squared. X times 1 is x. 1 times x is x. 1 times 1 is 1. Drag down the left side. On the right side, x plus x is 2x. And then at this point, since I have x squared terms and x terms, I want to get everything on one side equals 0 so that I can hopefully factor, set each factor equals 0, solve for x. So let's subtract 7x and add 5. Subtract 7x, add 5 on both sides of the equation. So we get 0 equals x squared minus 5x plus 6. And then that's a basic trinomial. So we're looking for two numbers that multiply to 6 and then add to negative 5. So multiply to 6, add to negative 5. Negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. Set each factor equal to 0, and you get 2 and 3 as your two answers. Now, since this is a radical equation, we do have to check our answers to make sure that we don't have an extraneous solution. So I'll do 2 first. So I'm going to check that x value of 2 first. So 7 times 2 minus 5 minus 2 equals 1. So 14 minus 5 minus 2 equals 1. And notice I'm not solving the equation. I'm just simplifying it. And sure enough, as I kept simplifying the left side, it got down to 1, and the right side already was 1. So that works. X equals 2 is an answer. It works. Then you need to check the other answer. So now I'm going to check x equals 3. So I just go back to the original equation. Wherever I see an x, I'm going to plug in a 3. So 21 minus 5 minus 3. And then square root of 16 is 4. 4 minus 3 is 1. So yes, 1 does equal 1. That is a true statement. So both of these answers work. If one of them got you down to a statement that wasn't true, that's where you would cross it off and it would be an extraneous solution. Hopefully this helps.